Okay. Is this working? Okay, we're back. I just had to return some keys to one of my neighbors who was away. Yeah, let's see if there's a nicer way to do this. This is not going to be efficient, but it's got to be a nicer way, right? Can I do this? Yeah, I figured that would happen. Does that work? Oh, hey, that's not bad actually. Okay. Missing. Yeah, it's not bad. Okay, good. Okay, so now if we move to the right, if I press it again, place wire on blank, it checks all of the neighbors. One of them is a net, add to existing net. Yeah, that is working. And if I move to the right, again, now it'll create a new net because yeah, so now there's two nets. Okay. So yeah, we need to deal with this case, then we'll deal with that. So we will do equals neighbors 1. Okay, so add to existing net. And I don't need this anymore. Okay. Where's my documentation? Here. Okay. Actually, so here I think, I mean, if we assume that all of our data structure invariants hold, so it's safe to add this coordinate. Yeah, okay. So So n dot, so add n dot cy, and we will do grid of cy cx equals n. Okay. Now let's run it. Also, I'm going to change this to be button push so I don't get a bunch of garbage on the log. Where is that? Just make things a little easier to work with. So right now I'm at position 0. Oh yeah, I was holding it down. Okay, create new net. Now if I move to the right, add to existing, no work. Okay, now if I move down 2 places, create a new net. Now if I move up 1 place, merge all neighbors. No work. Yeah. Oh, I just realized. But what if... Oh no. This isn't going to work. Because a net has to... shoot. Let me try and explain what I mean here. Like... So like, let's say there's already a net up here and you're in the middle of drawing some nets over here. And maybe you draw this one right here. But if you click here to place a net, what'll happen in the way I'm coding it right now is that it'll connect everything together like this. When in reality, that's probably not what you want. Like, it should be possible to draw 2 separate nets. So like, no, I meant to do that. And then here, it should be possible to draw 2 separate nets. And then if you like, you know, let's say you erased this, it should be possible for you to like keep these separate. You see what I mean? But right now the way I'm doing the logic is, if you place any net, like let's say you clicked here to place a net, that'll scan all 4 neighbors and it'll connect them all together. But that's probably not what you want. Like maybe you just wanted to do that instead of connecting it all together like this. In other words, like, there's no easy way for me to know what the user meant. Did they want to connect it together or not? I had the same problem with gates, which originally the way I did it was just to, or I haven't done it yet, but the way I was planning to do it was to like remember, okay, the last wire you placed is here, but then only connect it to this gate if you clicked here and then on the next place wire call you were in here, which would cause it to get connected. I kind of have to do the same thing for nets. So the only neighbor, okay. The rule is the only neighbor we check is the previous. That's the rule. Yeah, okay, let's do that. Well, before we do that, I think I want to put in some drawing because I'm tired of looking at the log to see if I did it right. And so that means that there is no merge case. There should never be more than one neighbor. Oh, but wait, that means... I gotta rewrite all of this. Because now this case up here, wire on wire no work, doesn't make sense anymore. Because if I want to connect a wire to an existing wire, like, what I'll do is click and drag, click once here, and then click once there, and that marks this should connect to that, and then it'll do all the proper like updates and stuff to connect them. Right. So nets are always placed between the previous and the current. Okay, I don't think I need to rewrite it. I'm thinking about it now. I don't think I need to rewrite it. Oops. I think I just need to add a special case in here. So it's not no work. There is actually work. Needs work. Yeah. So, but all of this is like pretty much... So, yeah. I think this create new net case is okay. And this add to existing net will work, except the rule is not add it to any neighbor next to it. The rule is add it if it's connecting between previous and current. So here we will do is if neighbor so this is not true anymore. This is, well, actually, wait a sec. Is there an abs function? Okay. If prev is neighbor, what did I call it? Last wire. If so, actually here, abs cx minus last wx plus abs cy minus last y or y equals 1 equals grid. Last wire y, last wire x. And I'll just call this add to previous wire. Then whoops, not like that, like this. Just to make sure. So you know what? Let's do this. Local last wire is neighbor equals and whoops. Last wire X. Note that grid has sentinel values outside y equals 0 to 63 to, well, whatever, that's all I need to say. Has sentinel values for y equals -1 and y equals 64, as well as for any x value. Okay, so the previous is that one, and grab.type equals net. So the Manhattan distance being 1, So now here, we will do this. If the last wire is a net, then here we will just use prev, since we went to the trouble of creating it. Okay. And in this case, we do it here, we do it here. Actually, no, I still think it's correct down here, I think. So what's this? So this is the blank case, junction, gate, wire on wire. But no matter what, when you place a wire, like, you're always going to set this, right? Yeah, absolutely, always. Okay. So actually, this is the only place, well, we need to deal with gates and junctions, but this is the only thing we have left for at least just drawing nets. This is the wire on wire. This is wire on blank. So this is the case where we need to do a merge. So if last wire is neighbor, then a bunch of stuff, else we can do a log here. Log, no work. Now here, this is where we need to merge previous and current. If cur does not equal previous, then add all. Oh, but we have to deal with the gates too. Okay, yeah, okay. Add all of curs, gates, and coords to prev. I think that's all we need to do, actually. What do we have in the nets? Gates, coords? That's it, yeah. Oh, and, okay, actually, before we do that, for each of curs coords, edit them in the grid to point to prev to do. Each of curs gates, edit them to point to prev. That's when we implement gates, which I haven't done yet. So let's do this first. 1 to length of cur.cy. Let's just put in a safety assert here. Why not? Equals length of cur.cx. dot cy of I, cur dot cx of I, this is a little annoying. Let's just call this C for current. What is pointed to by the last wire we placed. Let's just call it P. And then finally, delete C from nets global. Global nets list, which is easy, just del nets C. Equals P. We can input spaces. Grid of c.cy of I, c.cx of I equals P. Okay. For each of C's coordinates, edit them in the grid to point to P. Also add them into P's coord list. Now we will do add P dot cy of I. For G in C dot, what did I call it? Just G? Yeah, just G. Add. Maybe we should make this a set instead of a list. Yeah, I think we should do that. So now we will do P dot G of G equals true. To do edit G to refer to prev to P instead of C. Let's see if there's any syntax errors. No syntax errors. I don't want to run it yet. I want to think about it before I run it. Log, how did you make a gate? And log, how did you make a junction? Okay, so as we press Z, oh boy. Runtime error. Attempt to index global. Oh, I still have a cur. I need to see. Okay. Wire on blank, create new net. Wire on wire, no work. Wire on wire, no work. Now, if we move to the right, now it should connect to previous. Oh boy. Okay, prev doesn't exist. So this is that, and that, and that. Okay, try that again. Wire on wire, no work. Oh no, wire on blank, create new net, wire on wire, no work, wire on wire, no work. Now, if we move to the right, wire on blank, add to previous, wire on wire, no work. Now here's where things are going to get complicated. If I go down here, this is going to create a new net. Wire on blank, new net, but now if I go up and press it, it should merge the two together. Merge prev and cur. Okay, great. Let's draw it. Let's actually start drawing these things. So now let's do function draw grid. And let's do OX, OY. Draw the 16 by 16 subgrid starting at dx, dy. If full is truthy, write all of grid into map so we can save. So for I equals 0 to 15, j equals 0 to 15. Oops. Okay. Now for each of these, so local O equals grid of OX plus I, no, actually, OY plus I, OX plus J. If O dot type is a net, then haha, very funny. Now what we do is we check neighbors to determine what tile to draw. Oh, and the net can be logic high or logic low. For now, we'll just draw it as logic high, I guess. So we'll start it on number 32. Local. Well, okay, let's start at val 1. So this is going to be, I don't even know what to call this. It's like the lookup value. So love for lookup value. So now we can do this trick again. Oh, wait, I think I deleted that. So, neighbors, 1, we'll do 1, 0, -1, 0, oops, 0, -1, 4, and in all neighbors do dx dy equals unpack n. Well, let's just call this d, I guess. N equals grid of dy. Wait a sec. This is y plus I plus dy, right? Ox plus j plus dx. Yeah, it's fine. Like, if we can keep this, so what's the stat here? I think stat 1 is for processor. Yeah, stat 1. So debug start of draw grid stat 1, and we'll do that again at the end. This will help us see what the performance cost is for all this extra like indexing, and because there's probably a way to write the code which is a little bit more efficient, but it might not matter. So this is the neighbor. So here I'll put a to do in, deal with gates. But for now, I need to wait. Two, 4, 8. Let's just clean this up a little bit. So here we'll do if n equals O, love plus equals W. And then we will do we would also add W to love if n was a gate that connected to this net. Okay, and then finally, local tile number is equal to, for now, we'll just use the logic high, is 32 plus, now where is that? I think that's in here. Well, it is a global, actually, so let's put that back where it was. Although maybe I'll put it above init instead of all the way down here. Or I'll just put it in here. Oh, right, I need to finish writing that. Plus lookup table of lookup value. Now we do mset ox plus j oy plus I tino. If net, then, and here we'll do else. Zero. And we also need a to do cases for gates and junctions. Okay. So for the 16 by 16, we will index the relevant portions of the grid. If it's a net, we check the neighbors to come up with the tile number. If it's not a net, right now we need cases for gates and junctions, but we don't have them yet. We clear out that part of the map. I think that works. Something wrong with my indentation. If net, then all of this. Oh yeah, no, that's fine. Oh wait, hold on, where's the end for this for? For D and all neighbors do. Ah, I see. So this needs to end here, which means this, wait, what's going on? Something's wrong with my indentation. What's going on here? So this end is for the function. Then we have two for loops and end. Then we have the if for the type. Oh yeah, I think I fixed it. Okay, no more syntax errors. Now let's actually use it. So in here, we will do, what did I call that function? Draw grid. We'll just leave that 0, 0 right now. Uh-oh, it's not working. Oh, wow. Draw grid. Actually, that's really not bad, though. Yeah. Sorry, I thought it was more expensive at first glance because I need a space here. Yeah, that's not bad. That's like 2% of a frame. Yeah, we can deal with that. So how come I can't see anything? That's definitely not right. Debug. IJ Tino equals so 0, 0 should have tile number 32, right? Yeah, that works. So now if I move to the right, so now we have 34 and 35. 34 and 35. Well, the 34 is wrong, but we can deal with that. Whoa. Oh, that's cool. I didn't know there's a little keyboard shortcut there. Well, it's still a little strange that I don't see anything. Maybe these indices are wrong. What the heck? So I and J are definitely okay. What's wrong with OX and OY? What? Oh, oops. Oh, I wonder if we're getting in here. What happens if I do this? Oh, I know why. Duh. This doesn't draw grids necessarily. So what we really need is the actual called a map to actually draw the thing. So how do you use this function? I'm looking it up here on the left. Draw a section of map. starting from cell X, cell Y, at screen position, SX, SY. By width and height, so we want 16 and 16. Hey! Okay, yeah, so this lookup table value is probably wrong. Okay, yeah, something is wrong with my lookup tables, but that's okay. We will check them out here, so this one's correct. You know what it is? I'll bet you it's my weights that are wrong. So this is, yeah. I'm doing XY. Ooh, almost. Huh. Cool. Well, kind of. It kind of works. There's a little bit of weirdness going on. So I think there's something wrong in here. So 0 is 0. That makes sense. 1 is 1. That's just to the right. Okay. This is just down. So 0, 1, 2. Okay. This is to the right and down. This one is just to the left. 0, 1, 2, 3, yeah. It's gonna take a while here, but whatever, bear with me. This is 0, 1, 2, 3, 4, 5. 1, 0, 1 is left and right. Number 14. What's 32 plus 14? 46. Yeah, that's right. Right? I think that's right. And then this is left and down. 1, 2, 3, 4, 5, 6. That's right. And then this is the bottom 3. So that should be 42. That's right. Oh, I just noticed something. There's 2 14s and 2 12s. So that's definitely a problem. Okay, so anyway, this one was the bottom 3. Now let's do this one. This one is just up, right? Just up. This should be 4, not 14. And this should be up and right. Yep, okay. This should be up and down. Yep, okay. This should be up, down, and right. I don't think that's right. All right, so this is 0, 1, 2, 3, 7, 11. 11 is 1, 0, 1, 1. That is up, down, and right. And this should be 9, I think. Okay, this is now up and left. 0, 1, 2, 3, 4, 5, 6, 7. That's right. I think it's probably right now. This is up, left, and right. Yep. This is 1, 1, 1, 0. So that is up, left, and down. Yep, that's right. And by process of elimination, this one has to be right. Yeah, okay, great. Yep, okay, yeah, this is working. Wait, maybe not. Oh no, I think that was right. Okay, one thing I want to do is first let's get rid of the debug statements. I think we're okay for now. And one thing I want to do is debug the number of nets. Number of nets, 1, still 1, still 1. Okay, so now if I go here, number of nets 2, still 2, just 1. All right. So now I should have 3 nets. I do. I need to be able to erase, but so now here I should have 3 nets. I do. Now if I connect this to that, that's funny. I have 2 nets, and then if I connect this like that, just 1. Okay, great. This is mostly working. There could probably be some hidden bugs, but that's okay. Oh, I see, actually. Okay. Yeah, now we're up to like 9%. Yeah, draw grid gets more expensive as the scene gets more complicated. Number of nets, 57. Could be, I don't know. Okay, one sec, this is getting annoying. Let's move this back to like that. Let's just connect everything up in one big net. Actually, let's double check. Right now there should be 3 nets, I think. Yep, and there are. Yeah, I think this is mostly okay. Okay, so when everything is completely full, we're up to 30% of the processor time. And there should only be 1 net. That's right, there's only 1. Okay, so the next thing we need is to be able to erase wires. Which means that we need to implement like a DFS kind of thing. Oh, here's a question. If I do AB equals unpack 1, 2, 3, just 1, just 2. Okay, yeah, okay, that's fine. So they don't actually have to have the exact same number of elements. Let's see. Yeah, we're still going space. Now, we need to be careful about how we write this DFS because it's also going to get used when we load from the cartridge. I kind of want to implement erasing first. So for erasing, I'm not just well, okay, I am just sitting here, but like I'm not doing nothing. I am just in my head imagining how this is going to work. Well, you really have no choice. You just need to go to all of the neighbors. So let's say I erased this node right here. I'd have no choice but to do a DFS on this, neighbor, build a net out of that. And then for each of the other neighbors, if they're in the net I built, then it's fine. If not, do a DFS and build a net out of that. There's really no other way. I'm starting to lose steam. Is there something easier I can do? Well, DFS is not hard. Not to mention that we have this spiffy little neighbors thing, which I may as well move into globals. Was there a comment with that? Little helper to simplify the look of code that checks neighbors of a grid tile. So now here, what we need now is a function called erase wire, I guess. Nah. I was thinking like if we clear the last wire, it might prevent like some confusion later on when the user tries to do something and it just like does something bizarre. If c.type is not equal net, then log try to trace non-net to support this. And here we'll just return. Now, I mean, when we do DFS, we want to be able to know, we need a scene table. The really annoying thing about that is that I've been keeping my coordinates as 2 values instead of just one linearized coordinate, which I'm now regretting, because when you do a DFS, it's like, I don't want to check, you know, because like, anyway, you can probably imagine what I mean. Maybe we should just save the linearized coordinates. Actually, there is another dumbass thing we could do though, which is convert the coordinates to strings. Nah, I think linearizing is the best. Okay, yeah, let's just linearize. So for maximum well, this wouldn't give us the best efficiency, but it gives us the most flexibility. Grid X, grid Y, or G size X equals 128. G size Y is 64. Accessing these globals, it adds cycle costs, but you know, whatever. It's the price you pay to have flexible code. We can still afford it for now. Someone flying a drone. Anyway, I think I'm too unfocused to do this right now. Yeah, let's just give up for now. I'll come back to it.